So I have the example lesson problem that's pulled up from the previous lesson. And so in that one, again, this was our initial amount minus x, and we had an equilibrium. Initially, we didn't have either of the first two parts. We added x's because we made them, we have x. Then we had our K expression, products over reactant. We leave out the water because water is always considered a liquid. Everything else is AQ. We knew Ka from the problem up here. And then we plugged in, it turned out to be x times x, so that's why that's x squared. And then we put this term in. Last time what we did at this point was we solved for Math Papa, we got this number, and then we solved for pH. Now I'm going to show you the shortcut. The shortcut is that if we solve for x right here, and we actually, let's see how small x really is compared to that 0.25, because we already have what x is, right? So I'm going to take it, I'm just going to put it on this side. So x is the 0.25 minus 0.11116. Now, if you look at this number and you look at how that rounds, that actually, if we're trying to round it to 2 sig figs, that actually rounds to being 0.25. Do you see that? So this example is actually an example that's a little close, where it's not as obvious. What if that number hadn't been 0.1006, but what if it had been this? You get plenty of x's that are that small. Look at how close it becomes to 0.25 at that point. So what we say is that we assume, and this is because it's a weak acid, and it usually works if this isn't much smaller than like a 0.1 or 0.2 or 0.5, and if this exponent is like more than -4, you have to check it usually if it's around -4. But if the difference, if you kind of look at this 6 and then you see that it's a great big difference in your initial amount, your assumption's almost always going to work, but we do check it at the end to make sure that it works. The rule of thumb is that if the x that you calculate, when you assume that this is too small to matter, I'm not getting rid of the other x's. I'm not getting rid of these ones. We're just assuming this is too small to matter compared to the 25. If this number that we solve for x over x times 100% gives us less than 5%, then it's okay to do it. So this is our little check, 5%. We're trying to figure out, is it 5%? We would do this normally after we solve for x, but I'm just letting you know, since we already know x, we're going to see if it's okay to solve for it this way. So we have 0.001116 divided by 0.25, 0.001116 divided by 0.25 times 100. So you can see that's not 5%, that's 0.4%. It's totally okay for us to assume that 0.11, that this number is way smaller than 0.25, and it won't be enough to change the pH. So let's actually see if that's true. So we're going to pretend we don't know this. So pretend we don't know, and we're going to go ahead and do our assumption. So what you do with the assumption is you just make the math easier, basically. So we have this number equals x squared over 0.25. Voila, our math is so much easier. And look at how nice it is to use your calculator when you're doing this. So we have 5.0, but 5 times 10 to the minus 6th. And now I'm just multiplying both sides by that 0.25 to get that to cancel. So times 0.25, and I'm going to take the square root of it. And again, I'm using my little calculator function, second answer, to give me my square root number. That's what x is. So it's telling me that x is 0.001118. First of all, look at how close, just assuming that x didn't matter, first of all, look at how close it is to this number right here that we actually calculated, literally. It's very, very close. The difference is like way out in the 1, 2, 3, 4, 5, 6, 7th decimal place. So that's a good one. Now let's just take the pH of it. The negative log of that answer is 2.95. And you see that the only difference here is right there in that decimal place. And we're going to have these numbers wide enough for you so that that little tiny bit of difference isn't going to make a difference. Or we might just say, it's going to be, we'll accept like maybe 2.93 to 2.96, something like that. So this is the assumption method. You should use it. You should use it. You should use it. Promise you it's going to save you time. Don't jump over to Math Papa and try to do it all the way. There's a lot of reasons not to do Math Papa when you have weak acids or weak bases. It works for both. And you make the assumption. The big deal is just to make sure that the number, or the x rather, that you're getting rid of is that one. You are still keeping this x, because that x is beside 0. Anything besides 0 is going to be an x.